Good day, grade 8s, and welcome to mathematics. Today we will be looking at the relationships and input and output diagrams. So from grade 2 to grade 8, we've all done spider diagrams. In grade 2, our spider diagrams looked like these. Do you miss them? I know I do. Okay, but now we've all grown up and we've moved on to grade 8 spider diagrams, which look like these. Okay, somewhere along the line they've decided we are all grown up and took away our pictures, but I'm sure you can do these. On the left hand side we all have our input values, on the right is output values, and in the middle we have our rule. So how is these different in grade 8? So in grade 8 this is basically what our spider diagrams look like. Most of the time the only difference is they are a little bit more difficult. The concept remains the same, however, the rule may be a little bit more difficult to work out. We also start using mathematical terminology such as input, output, and rule. Okay. So what do we do in grade 8 that is different in grade 2? Well, the biggest difference is that our spiders don't look like spiders anymore, and the calculations are a bit more advanced than they were in grade 2. However, these should not be a concern to you since you work so hard in mathematics. So when we look at our grade 8 spider diagram, we have input values 3, 5, and 7. We have our rule that says you have to multiply by a negative 3, and therefore we can take our input value 3, multiply it by negative 3 and get to negative 9, which we can place as our output value. We can continue to do this with negative 5, place it in our output, and negative 7, which is negative 21. That is basically how our spider diagrams in grade 8 look. However, since we are all grown up now, we can also start placing our spider diagrams values into tables. So the other part of this is with a table comes an algebraic equation. So for example, we can be given these. So on the left you can see we've got y is equal to negative 3x plus 4. We also have a table where x is our input, y is our output, and they've only given us the answer for t, which is negative 41. However, we don't even know what t is. So in each of these cases, we are missing an input or output value. So what do? We have to determine these. So let's look at our input value 1 for yellow. So we take our equation, we substitute the value of x, which is 1, and we calculate a value for y. We can continue to do this for x is 2. Substitute the value for x, get to negative 6, and 4 gives us negative 2. And we can go on to do this for all the other inputs. I'm going to halt there at blue, which is x is 12. So for x is 12 in our table, they have given us a value p. So this means that in that specific equation, y now becomes p. So we have to substitute the p into our equation as well as 12. So if our basic equation looks like this, y is equal to negative 3x plus 4, we substitute p into the place of y, and we don't have a value for, well, we have a value for x. There we substitute x's value as 12, and then we can determine the value for p. Oh my goodness, I've made a calculation mistake here. Let's see if I can correct it. Okay, that should definitely not be 13. Okay, anyway, let's just move on. Okay, here we've got x is 15. Okay, so we can take that information, place it back into our table if they ask us. Otherwise, we can just leave all of these calculations for your teacher to mark as part of the answer. Okay, what else is different? So the second part of grade 8 functions and relationships is that sometimes we're given some input values, some output values without a rule. So if we look at this example, we have values for 1 and 2 and 3 and 10 and t. We've got a whole table, but we don't have a rule. In this case, you revert back to what you've learned in the previous lesson. So look at the common difference between the terms 1, 2, and 3. Between -3 and -1, we have to add 2. Between -1 and 1, we also add 2. Therefore, we can assume that A's value is 2. Can you still remember where A has to be substituted in? Our basic equation was y equals ax plus c. So in this case, a is 2, as we have just determined, substituted into our equation and test the equation. Let's see if it works. Y is -3 is 2 times 1 plus c. So 2 times 1 will give me 2. We don't have a value for c yet, so if we simplify further, we get c equals -5. Let's continue. Let's try out and see what happens with yellow. Remember, we have to determine the value of c. We don't know it yet. We've only done one example. Or some yet, so that is not confirmation enough. So let's see what happens with 2. There is our basic equation with the information we have. Substitute our values, simplify, and again we see that c is -5. We can continue this for 3 as well, and again we get c equals -5. After we've done 2 or 3 of these, we can now say that we've proven that c is -5. So now for the last 2 columns in our table, we have to determine a k and t. These are unknowns, and therefore we can place them into our equation and see what happens. So y in this case would be k to x minus 5. We know that x is 10. Substitute it further. 20 minus 5, therefore k is 15. In the last column, we have x is t. Substituted into our equation and simplify. Therefore, t is 13. And that basically tells you how to answer the tables. If you can't remember how to determine the common difference or what the general algebraic equation is, please revert back to the previous lesson and check out that video. Please let me know what you think of this video, and good luck for the rest of the day.